All right, there we go. That should be fixed. All right, thank you. Remember that we are online. If you have any questions, please go ahead and post to Piazza or to the feed there. I'll make sure that this actually works here. I still don't know if it is working. Okay, yeah, there it's finally working. Thank you. Sorry about that online. Thank you for pointing that out. Anyway, graphical user interfaces and event-based programming. It's pretty straightforward. It doesn't matter what language you use. It doesn't matter what framework you use. There are the same basic steps to designing and creating a graphical user interface. We save it to the end and we don't give it too much emphasis in this course because in reality, the vast majority of software is written not for people, right? It is written to interface with other software. It is for automation. If there is a pesky human sitting at the computer, a PEBCAC user, that is pointing and clicking a bunch of stuff, then that defeats the whole purpose of automation. Now, the vast majority of consumer-facing programs are, of course, going to be graphical user interfaces. Your phones, right, games and stuff like that, that is meant for human-computer interaction, HCI. But the vast majority of actual software, that's just the tip of the iceberg. The actual iceberg that's under the water is all the software that's built to interact with other software. Up till now, but it does require a little bit of different thinking, right? Mostly because there's what's called modular design, modular interaction, and also asynchronicity, which is what we're going to cover as concepts. Up to now, most of your stuff has been sequential programming. That is, you've got a program that goes A, B, C, D, E, right? If you've got commands, it goes top to bottom, left to right, essentially. Of course, you could call, you could do a loop that repeats and goes back up and then continues, but otherwise it's sequential design. What we're going to be looking at is event-based programming, which is different. Because it requires a different way of thinking because there are multiple ways of doing the same thing, and it doesn't necessarily have to be in sequence either. A typical program that is sitting there waiting for human-computer interaction is going to be sitting there in what's called a poll loop. And it's going to be asking, well, what have they clicked on right now, right? They don't have to click on A, then B, then C. They can do any number of actions in a completely different sequential order. And so you have to have a different mindset. You have to have a different way of designing things with that in mind. You can, of course, have what are called thin clients, which is basic web programming. Thin clients are going to be your web browsers, and you can design a web app that can be run on any browser. And then you also have thick clients. Thick clients are going to be programmed in one particular language and compiled for one particular system. You can't necessarily take an iOS app that runs on your iPhone and port it over to Android, right, without any changes. It's different languages, it's different frameworks, it's different everything. There are frameworks that are built on top of those that try to abstract that away that then can be compiled for one system or the other, but it never gives you what's called the native look. Right? You'll have these applications that don't look like they were built for iOS or they don't look like they were built for Android. They won't have that native kind of look. Right? And then again, event-based programming where you have human interactions that are defined by events. Somebody clicked that button rather than execute order 1, 2, 3, 4. It's somebody clicked that button. What should happen? Somebody double-clicked that button. What should happen? If somebody clicked that button and set it into a different mode, you want to save this file? Okay, choose a file name to save. We don't want them then to go over and do something else that is not relevant to the current task at hand. So you also have to have some sort of a modular design or modular control so that you are preventing bad user inputs. It's completely different from command line arguments. Remember when we started reading stuff in from the user? Please enter an integer. And they said, well, what happens if they just sit there and mash the keyboard? Right? They could give you bad input. A good user interface design will prevent that kind of bad behavior and force a user into only good behaviors. Right? Again, instead of specifying what happens in a program, A, B, C, D, you specify what happens when that event occurs. When that person clicks on that button over there, then this sequence of events should happen, sequence of instructions should be executed. When they click on that button over there, these different sequence of events should be executed. And it's not like they clicked on button A and then B. They could click on B and then A, or they could click on B and not A, or they could click on A and not B, or they could just do nothing and sit there and the application just continues running without any input at all, right? So it takes a little bit different thought process to look at these things. I don't want to get bogged down in the history. Graphical user interfaces are quite old at this point. Xerox deserves the credit for inventing the first desktop windowing system that was then stolen by both Apple and Microsoft. Apple came out with Lisa, the first consumer-facing a computer and a graphical user interface system where it was trying to emulate a desktop, right? Where you had a desktop, you had files that with the mouse that you could double-click and open stuff. You had a trash can down over here. You had multiple windows, and then you could bring one to the foreground, and you're working on that. You're focused on that, and there's stuff in the background. Macintosh came out later on. Windows came out in '85. That's the first version of Windows. And throughout the 90s, then the graphical user interfaces exploded, and making computers possible to be used by regular people. Up to that point, it was all mainframes, and you had to be basically a programmer to even use basic software. But it kind of released with the graphical user interface program. It didn't mean that you had to program anything. You could point and click on stuff, and now it was open to consumers. Throughout the 2010s, you had mobile devices and interfaces with different events and new events, right? With a traditional desktop computer, you have a mouse, and so you have click events. With a phone, you don't have click events anymore because you don't have mice. What kind of events do you have now? You have tap, double tap. You have multiple finger, zoom in, zoom out. You've got rotation on your finger. You've got a whole bunch of different ones. With different input devices comes different events. For example, the Microsoft Kinect, right? You can, in World tap. With VR, you can do, and AR, you can do different things with your finger gestures and stuff like that. So it continues to evolve. Input devices continue to evolve, meaning that things have to be updated. I can't tell you how terrible it's been to do the VR course because everything always changes. I've been doing it for like 5 years now, and the SDK completely changes every time. Every year I offer it, and because new ways of doing things always come out in VR. Right? There are lots of different frameworks that you can learn, pick up. We're not going to focus on any one particular one. We're going to focus more on concepts that are interchangeable across all of these frameworks. In C, we're using GTK. That's because that's the de facto one. There's really, other than Motif, I don't know of any other graphical user interface frameworks. GTK stands for the GIMP toolkit. GIMP is another acronym for GNU's image manipulation program. It was developed by this one guy that created GIMP, which is a Photoshop clone, free and open source Photoshop clone. And he developed GTK along with that because he was sick of using the old school kind of graphical user interface frameworks. And so he threw them all out, made his own so that he could create this Photoshop clone. You also have GTK Plus, which is a C++ port of that. XW widgets, etc., Qt, a whole bunch of other things. But they all have commonalities. They all have the three basic components. A way to build what's called widgets, a way to define a layout, and then a way to define events. And we'll get to that here in a moment. With Java, it began with AWT, Abstract Windowing Toolkit. Then on top of that, an abstraction was built called Swing. On top of that, yet another abstraction was built called JavaFX. Each one of these iterations makes it easier and easier to create graphical user interface programs. One that I would show you right now is, not just the website, I guess, is Android Studio. It's a WYSIWYG. What you see is what you get development tool. So I'll just go down here to a screenshot. You do have, of course, a coding environment like you would have with the CS50 IDE. But you also have this graphical user interface layout environment where you can say, I want a button right there. Okay, just go ahead and drag and drop this button. And that creates that widget, that creates and the layout at the same time. What happens when somebody taps that button, right? Then you go over to the left side here and define the functions that should be called and what should execute within those functions, right? They want to save a file. They hit the save button. You code the code that is necessary for saving that file or whatever. But you have WYSIWYG development environments like this for pretty much any of these frameworks. iOS, I'm sure, has one with Swift. I believe that GTK does have one. It's an add-on, though, because it's all free and open source. All right. So that's the very, very brief breakdown of the history and overview of graphical user interfaces. Let's talk about the actual components in a graphical user interface program. You have what's, first of all, at the lowest level, or at the highest level, or no, lowest level, let's say. It all depends on your perspective, is a windowing system. This is usually provided by the operating system, so you don't have to worry about this. It handles the low-level interaction with your input devices and the rendering of all your graphics. So, for example, you don't have to write the code that renders, like, say, this window right here that I'm moving around. Every single pixel on this is defined by some piece of code somewhere. You don't have to worry about any of that. It's taken care of by my Mac operating system here, the windowing system that's built on top of that operating system. If you move this over to SUSE Linux, you have several choices in the labs. I believe you have, what are some windowing systems on SUSE? Anybody a Linux user? I forget. Yeah, what do you use? A what?
I forgot what they use, but it's on the Chromebook where it has the Unix system on there.
Okay, Chromebook would probably still be Windows, or Chrome OS or something like that. Yeah, whatever it is.
It's still Chrome OS, but it has the Linux built into it.
Okay, all right. Under the hood, there's still Linux, some Linux there. KDE is one off the top of my head. That's a windowing system that is built on top of any any Unix operating system. You can choose that, or GNOME is another one. I think GNOME is actually the default in the labs. GNOME, G-N-O-M-E, GNOME, or GNOME, however you want to pronounce it. Those are windowing systems that are built on top of operating systems and handle the moving of the mouse. If I move my cursor here, several pixels over, that was more like 30 pixels there. It handles the rendering of that. It handles the input device, whether or not it's a touchpad, a mouse, or something else entirely. And it, of course, handles all the rendering. You also have a Windows Manager. A Windows Manager is it basically takes care of the interaction of applications and widgets. Widgets, what are widgets? Well, widgets are just graphical user interface components. Like a button, for example. And we'll list a couple more here in a second. It controls the flow of an application by registering and handling events. When you click on a button, what the windowing manager does is it sends a signal out to everybody saying, hey, this button was clicked. Whoever's listening for this event, guess what? This event happened. Do your thing. So that you can have multiple listeners for, if you click this button, this listener, and this listener, and this listener can all be doing their own thing, all independently. Right? You could have multiple listeners for one event, for one particular widget. Usually you don't do that. Usually you add one handler. But you can have multiple handlers and do things asynchronously and even in parallel on different threads. Again, an event is an action that is initiated outside of the program. You do not write code that says, in the event of a click event, if button is clicked, then do this thing, right? You don't do any of that. What you do is you create a button and you say, by the way, windowing system or windowing manager, when that gets clicked, call that function over there. You never write any code that deals with the button directly, right? Finally, widgets. Widgets are basically just generic graphical user interface elements. For example, like I already said, a button, right? They may be visible or invisible. They may be interactive or static. A button is interactive, but a text box is not, right? So some examples here would include buttons, right? Text boxes, right? Static. You could also have text boxes for input, which would be dynamic. You could go up and you could start typing, right? What other kind of widgets have you seen before? Oh, say what? Buttons? What else? No? Sliders? Good, right? You want to increase a value or decrease a value, right? Labels? If you give somebody a button, you probably better put a label on that gives feedback to the user of a hint of what's going to happen if you click that button, right? Save, right? Or if it's not a label, what's the universal icon for saving? It's a floppy disk, right? Even though floppy disks don't really exist anymore, it still is that thing, right? You have also, say, menus. And there's lots of different types of menus. You can have drop-down menus. Say what? A canvas. For, say, drawing on something, that would be a widget, right? More complex widgets like, say, a date selector, date or time selector, a color selector, right? A color wheel, and then you can select the RGB value or whatever, right? Windows are widgets, right? Menus are widgets. I already did that one. Images, icons, etc. Right? Pop-ups, right? Prompts, etc. Also, finally, layouts, right? You have grid layouts, rows, or columns, right? Because when you actually put your widgets into this layout of a graphical user interface, you need to have it organized in some way. You can't just throw a button, throw a button, throw a button, throw a text box, throw an input, whatever. You want to make it look nice and you want to make it look organized because you want to give a good what's called user experience, right? You want users to be able to have, or at least not be frustrated by using your application, right? All right, so let's go ahead and we're going to get to the three fundamentals of these things in a second here. But before we do that, let's talk a little bit more about event-based programming. So event-based programming, again, is not sequential. Instead, it waits there, waiting for input. It waits for somebody to click a text box and start typing. It waits for somebody to click that button. It does this in what's called one big giant poll loop. It's kind of a busy loop. It sits there and says, has anything happened yet? No? Okay. Has anything happened yet? No? Okay. Has anything happened yet? No? Okay. Has anything happened yet? When somebody presses a button, that's an event. And then it sends a signal out to all the widgets that have been registered with that particular button, with that particular click event, and tells them, somebody click this button. Go ahead and start executing, do whatever you're going to do. Yeah? It would be like one big giant while loop, exactly. You don't program that yourself. You let the windowing manager take care of that. But it would be like while true, right? And then it just keeps going in an infinite loop, intentional infinite loop, until you close out the program, and then it jumps out of that loop, and that kills that program. An operating system is in one big giant poll loop, right? An operating system is just sitting here waiting for applications to run. Otherwise, if there wasn't a poll loop, then it'd be ephemeral, right? It would start the program, then it would die and be done, right? So it needs to keep going until there's some event that triggers some other code to run. So yeah, it's just one big giant while loop. Right? It's also more user-centric than the programs that you're used to. There are many ways to accomplish the same thing. For example, saving a file. One way that you can save a file is by going up to, typically, File, which creates a drop-down menu, and then you can go down to Save or Save As. What's another way of saving a file, typically? Command S, right? The power user way of doing it. Keyboard input rather than click, 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 click. There's also typically a floppy disk icon up there that you can go ahead and click that icon and it automatically saves. There are multiple ways of doing the same thing. Because you want to give the users a good user experience and be flexible. Some of those are going to be power users that know the quick command shortcuts, right? Control S or Command S or something like that. Others are going to need a little bit more graphical feedback. Oh yeah, that's the save button up there. Others will take the longer route and go up to save as if they need to do something else, right? And you need a way, there may or may not be a sequential control flow. For example, you could, if you have actions A, B, and C that are all independent, you could go action A, then C, then B. Or you could go B, then A, then C. You could do any permutation of those actions that are completely independent. Again, it all comes down to good UX, right? User experience. There. Which includes good interfaces will guide a user to the correct actions. Right? Good interfaces will dissuade or prevent bad actions. Dissuade, two S's. There we go. All right. For example, again, if you want to delete a file. Now that's typically a dangerous thing to do, right? If you didn't intend to do it. If there's this button up there that just deletes and then it immediately deletes it. That's what a command line is right? If I go rm this file, there's no undo. It's not going to ask me, are you actually sure that you want to do this? But a good user interface will say, are you sure you are about to permanently delete this file? Are you sure that you want to do this? And how does it do that? It comes up with a modal text box with that message that you are about to do something dangerous. Feedback to the user with two buttons, yes, I'm sure, or cancel, right? Now, typically, if you've got this dialog up, can you go and do other things? Not in a good user interface, right? You've got a decision to make, right? It's dissuading your bad actions by pulling this up and guiding you to the correct actions. You've got to make a decision here. Before you move on and go do other things, please make this immediate decision. So it's all about modal behavior, right? Modal behavior being, again, at any one point in the program, some actions, you may be prevented from doing some actions until you do other actions. We call it modal because you're in a particular mode. You're in this yes or no mode. Do you actually want to delete this file? And you are prevented, while in that mode, you are prevented from doing other actions. Right? By the way, I've seen plenty of good user interfaces that will have an even another layer, right? It'll say, are you absolutely sure that you want to do this? Yes or no? Yes. Okay, this is a permanent action, right? Another dialog comes up. Are you absolutely sure that you want to do this because it cannot be undone? Yes? Okay. Well, I asked you basically three times. You initiated the action. I asked you for confirmation. I asked you for confirmation of the confirmation, right? And if you actually did that, then it's on you if that was not what you intended. There will be good user interfaces will prevent bad actions like that, or dissuade them at least, okay? You also have what's called asynchronicity. So you do not want to prevent the user from doing in some modes, you don't want to prevent the user from doing other things. Asynchronicity is where you can do things asynchronously. I can go ahead and initiate this action over here, and while that action is running, I can go over here and I can do other things. Right? Good user interfaces allow you to have this asynchronicity. Let me go ahead and demonstrate that with a simple web app page here. Right? So all I've got is a bunch of buttons here that do certain things. For example, say hello. That just pops up a dialog that says hello. I can select an action here, option 0, option 1, or option C, which is 2, or another option here, which would be 3, 0, 1, 2, 3, right? I can interact with these two buttons. This is a basic button that loads up a dialog. This is a drop-down menu, and by clicking here, of course, it updates this text down here, right? It's just a dummy interface here. Now, what I could do is I could go ahead and initiate what's called an asynchronous delay. I'm going to go ahead and send a message to the web server asking for some data. And while it's doing that, while it's loading up, I can still interact with these buttons over here, right? I can update that, right? Let me go ahead and hit that again because it was only a 5-second delay. And I'm not fast enough there. There, option 1 selected. And then once it's done loading, it will say done, okay? But I was still able to interact with this page because of an asynchronous delay. It didn't prevent me from continuing to do this, right? Imagine if this was not asynchronous on a basic application like a word processor. You hit the save button, right? Saving may take a couple of seconds. Should you be prevented from typing while the saving is going on? No, that would not be a good user experience. You want actions to be asynchronous generally. Let me show you what happens when you don't have asynchronicity. This is what's called a busy delay. This will block any action this will block me from performing any action on the rest of the page until that's done. You can see that the button is still down there. So done, a busy delay is done. Let me go ahead and do that again and try to hit this button. I swear I did click on that button. But it's not going to do anything until that other action is completely done. It is not synchronous, it is sequential. Once it is done, then finally it registered, oh, okay, I was done. What happened while I was gone? You click that hello button up there. Okay, now I'll go ahead and pop up the dialog, right? It looks like lag, right? And that's exactly what it is. Imagine if games were like this, especially if it's on a network. If your local game froze up, waiting for somebody else's low ping, right? That is not that's not a good user interaction right there. That's not a good user experience. There's a question.
Where would you use that?
Where would you use what?
Busy delays or
Busy delays? Well, you generally don't want busy delays. I mean, if unless even if you want to use a busy delay, for example, you should not go on to the next step until this file has loaded, right? Then that you don't make it a busy delay. You go back to your modal design here. You shut off the ability to click that button until that loading is done. And then you turn back on that ability to click that button, right? And that's the way of doing it, so that it's not sitting there and with a busy blocking delay, right? You could do that very easily here by disabling this button or disabling this until this gets loaded. And then once it's loaded, have the event go back and re-enable this button over here, right? You can disable interactive widgets, right? In fact, usually they're disabled by default until you enable them. Sometimes, right? But that is asynchronicity. You don't want busy things. You don't want it freezing up, basically. That's a bad user experience, right? Events are always asynchronous, right? Because of the nature of events. They can happen at any moment, at any time, in any sequence. Yeah?
If in asynchronous events or delays or whatever, that means that multiple things are happening at the same time?
It could, yeah. If I click this button multiple times, 1, 2, 3, 4, I'm sending 4 asynchronous requests to the web server, right? Now, generally, you don't want this to happen because I don't want to waste bandwidth sending you the same thing over and over again. Just because you were impatient and click the button again, right? A better design would be to go ahead and allow them to click this, then disable it until it's loaded, and then re-enable it, and then they can go ahead and click it again, right? And that's not what I designed this with, but that's what I would do if I were to redo that. But you can have as many async. Now, this is technically JavaScript, and technically JavaScript is single-threaded. But actual programs and actual operating systems are multi-threaded. I've got, I think, 16 cores, or maybe it's just 8 cores. And then with hyper-threading or something, you can run 16 things at a time. At any one point, on a there's no such thing as a single-threaded processor anymore. Even your phones are going to have like a Intel Duo or at least 2 processors, 4 processors, quad, 8. I don't know why they didn't call that Ocho, but they should have. But you can have processors that can run multiple threads at the same time. So you can have a bunch of different things running all at the same time. In fact, if I did on CSE here, HTOP. On CSE, they've got 64 cores, and they're all running independently, running different things at the same time. That's not the same thing as asynchronicity. That's true parallel programming, or parallel computing right there. A thread is just a process. So there are small technical differences that we won't get into here, but there's a program, there's a thread, there is child processes, and a couple of other things. But threads, basically with one program can split into multiple threads so that it can do parallel programming. For example, if I wanted to sort something, I could have this very large array of 16 million elements. I could split that up into 16 different arrays and then farm those out to different threads and say, you do the first 1 million, you do the second 1 million, you do the third 1 million. And now I've got 16 processors all working at the same time. And basically, you could hope for 1/16 the time that it would have taken otherwise by farming it out to multiple processors at the same time. That's the advantage of parallel programming, parallel computing. Right? So yeah, for our purposes, a thread is simply just a program. right? A subprogram. Okay. All right. So let me go back over here. So again, events are, by their nature, are asynchronous, right? You can have, there may be thousands per second. In fact, there are thousands per second. Every time I move my cursor, even 1 pixel, that's an event, right? If I move the pixel all over the place like this, there were thousands and thousands of events that just occurred right there, right? So they could be very small, or they could be very big, like clicking a widget, like clicking a button, clicking on a static text, right? You can do that as well. Moving the mouse in and out of interactive elements. For example, let me come back over here, and I'll go ahead and zoom in so you can see it here. When I move my cursor onto say hello, the button say hello, what happened? Do you see? Kind of very subtly changed colors, right? Why? Because that's giving me visual feedback that you can that this is an interactive element. Something will happen if you click this, right? And the label says that it'll say hello, right? When I move it out, the color returns back. When I move it in and click the button, it also appears even darker now, right? Now, if I move out and I release my button here, or release my touchpad, is that going to be a click event? Nope. A click event is only when you have focus on something, you click down, you remain on the focus. I mean, you can move it around within the button here as much as you want, but once you release it, that was a click event. So a click event is actually a much more complicated event because it's a whole sequence of sub-events. Moving in onto the button, clicking down. You can move around inside the button as much as you want, as long as you don't move outside the button. In fact, you can go ahead and click, move outside the button, and then move back into the button, and then release it, and it's still a click event. Right? So there could be a whole bunch of different contingencies that you don't want to have to deal with. That's why we let the windowing manager and the windowing system take care of that stuff for us. Right? All we need to worry about is registering each one of these possible events with an event handler, right? And that's what's called. That's actually what it's called. It's called an event registration, and it's usually done by a callback. So event registration, when you can say that this particular button or this particular widget in general, on this particular event, click, hover, mouse in, mouse over, double click is a different event, right? Whatever event is relevant to what you're trying to do and design. Then you can say, go ahead and call that piece of code over there. How do we say that we need to call that piece of code over there in C? It's going to, what am I doing here? I am pointing to that function over there. Call that function over there. Right? Function pointers. Just like QSort, we had to hand off a function to QSort to say, call that function to determine if it goes like this, this, or this. Right? Are they in order? Are they out of order? Or are they equal? Right? And that's what's called a callback. Right, let me go ahead and kill that. Okay. So, how do we write GUIs? Well, first of all, you probably, I mean, it's not my favorite thing to do, but if you really like doing stuff like that, you just need 3 steps. Right? You need a way to create widgets. You need a way to specify the layout of widgets, and then you need a way to register events with it. With those widgets. I'm going to go ahead and just jump into a graphical user interface program here called GTK Keypad. Right? We'll take a look at the code here in a second that does this. But let me go ahead and bring it over here and then make it a little bit bigger so that we can see it. There we go. This is actually running on the CSE server and then being rendered on my desktop right here. And it's basically a keypad access. So let's just go ahead and interact with it. Well, when I hover over a button, the color changes, telling me that this is an interactive thing. So what's my user access code? What do you think? 1477. Enter. Access denied. Okay. 7777. Oh, okay. Clear that. I screwed up there. 0369. Enter. Right. Nope, that wasn't it. What do you think my password is? 1, 2, 3, 4. Exactly. Enter. Great. Access granted. Great. So how many widgets do you think are involved in all this stuff? Of course, there are a bunch of buttons. How many buttons do you see? 12, right? But do you see any other, all right? 12, yeah, 12 buttons. Right? What, 0 through 9, and then clear and enter, right? There's actually hundreds of widgets here. If we take a look at the code here, there's at least 200 lines of code to create this application. And there are a whole bunch of, there are those 12 buttons, but there are a whole bunch of other widgets here, okay? Before we do that, let's go ahead and understand this. How did I create this thing? I created first a layout, and I'll bring this over here so we could look at it side by side, right? So what do you think this layout actually looks like? Well, first of all, there's the main window. Guess what? A window is a widget, right? What about those buttons at the top, the red, the yellow, and the green? Those are provided by the windowing manager to begin with, right? But up here, what else do I have? A label, right? And then these buttons over here were actually provided by by the program itself, by the windowing manager itself.
Are
Right.
those considered widgets?
Say, yeah, those would be considered widgets because they're interactive, right? It's just that I didn't have to directly create them. Right? They were provided free of charge. Right? What else do you think is here? There's actually things that are unseen. There we go. That are handling all the layouts. That was ugly. These are invisible rows. Right? And in fact, even beyond that, around that is a column. Why is it a column? Because I'm going to add things top to bottom. Each row, I'm going to add things left to right. Within the first row, what do you see? Well, there's another label. What about that second row? There's going to be a text box. And by the way, when I click on that text box, I get focus, and you see the cursor is there. But if I mash my keyboard, well, it's donking up here. You can't hear it maybe. But it's not letting me type anything. Numbers or letters. Good thing, bad thing. Modal design. It wants you to interact using these buttons. Because it's expecting a number, we're not going to allow you to mash your keyboard and enter a bunch of letters. Right? Modal design. I disabled the manual input in that text box, and I'm forcing the user to interact with this program by using the buttons instead. Okay? What else do you see here? This is going to end up being a grid layout. What is that grid? It looks like a 4-row by 3-column row column grid. And I can start adding things top to bottom, left to right. So actually what I think I have in here is actually 3 more columns in there. And then I start putting in the buttons. I forget, but we'll find out here in a second. So even this simple application has dozens and dozens of widgets. In order to do this, I have to have the framework help me build these things, because I'm not going to go ahead, I'm not going to reinvent the wheel and design a label widget from the ground up. Right? I'm going to use what's already available in the framework, in the library. Okay? So let's take a look at the code that actually created this thing. First of all, I've got a couple of functions up here. Clear input, enter password. I wonder what those are for. We'll come back to them. Enter digit. Okay. And then finally, I've got the main here. The main is where I've built these things. Let me go ahead and zoom in on it so you can see it a little bit better. So I've got a whole bunch of GTK widgets. Right? GTK widgets, for example, like the window. Right? The main column. That sounds familiar. Right? I said that we have this main column right here. I've got the clear button, the enter button. I've got column 1, 2, and 3. Where are those going to end up? Column 1, column 2, and column 3. 1, 2, and 3. Right? I've got a horizontal box at the top, the mid, and the keypad. What are those? Those are the 3 boxes that I started out with. Right? I have not yet created them. All I've done is create GTK widget pointers. Now what I have to do is I have to initialize the entire library first. But now I actually have to start creating these widgets. Window, well, it's got a function for me to do that. GTK window new, right? And it's a top level window. It's the main window. There are a whole bunch of options that you can give this. There is a huge compendium of documentation that you would have to go through for, well, how do I create a dialog box? How do I create this stuff? How do I create that stuff? And it's just RTMing, reading this big giant manual of how, of which function to call that gives you whatever you want, right? I set the border width to be 10 pixels. You can see here that padding right here, this is about 10 pixels of width on the top, the bottom, and the left. Otherwise, the default would be 0, and you wouldn't have any padding there, right? It makes it look, it would make it look aesthetically bad. If all the buttons were right out on the edges of the window, right? You need a little bit of padding in there, and I chose to have 10 pixels of padding all the way around. I set the label of the window to be CSE 155E keypad access. Where does that appear? Right here. I also registered a signal on when the window is destroyed. In other words, when somebody clicks this red button up here, it will actually quit out of the program. If I didn't have this line right here, then this red button would have no effect. Thankfully, it does. You can build graphical user interfaces that are very malicious, right? And every time they try to close a window, 50 more windows pop up, right? Nice little joke. Right? Anyway, I create columns and horizontal boxes. I create a GTK V box. What do you think V box stands for? Vertical box. H box stands for horizontal box. It determines how you add widgets to the boxes, to the layout. Vertical box would be top to bottom. Horizontal box would be left to right. And so when I start adding things later on, it's going to the type of box, vertical box or horizontal box, determines how that layout occurs, or how that layout is ultimately going to be rendered. I add the main column to the window. I add the horizontal boxes to the main column. I then add the keypad, each one of those columns to the keypad, giving me this layout right here. Again, it was in order. I had to add this main column to the window. I then added 1, 2, 3 horizontal boxes. Then I added 1, 2, 3 vertical boxes. Okay. Lots of work just to do a basic layout already, right? And then I made sure to show everything. By default, widgets, at least in GTK, are invisible. They're not going to be rendered. Once I've shown them all, then of course they'll show up. And all their children, the widgets inside those boxes will also be shown. I set my label initially to user access. Remember, that's what it was when it originally started. Right? Later on, when I clicked enter, then that message changed to either access granted or access denied. Right? I wonder how it changed. I set the input box here to be non-editable. Like I said, modal design. What else did I do? I created all my buttons. Key 7, 8, 9, 4, 5, 6, 1, 2, 3. Why did I do it in that order? Because it's not 1, 2, 3, 4, 5, 6. It is like your keyboard, where there's 7, 8, 9, top to bottom, left to right. Right? Let's see, there's the enter button, there's the clear button. Now I register, so all of that was creating widgets. Again, what were those 3 steps? You need a way to create widgets, and I did. You need a way to specify a layout. I did by adding them to the containers. And finally, you need a way to specify what happens when each of those buttons gets clicked. So the clear button, when you get clicked, call the clear input function. The enter button, when you get clicked, call the enter password function. Any other of these buttons, 0 through 9, when you get clicked, call this one single enter digit function and pass into it this piece of data. You entered 0, or you entered 1, 2, 3, 4, or all the way up to 9. I showed the window, and I sent it into the main pull loop here. GTK main, that kicks off the main pull loop that is sitting there now waiting for input, waiting for events to happen. Right? Otherwise, it just keeps rendering the same thing over and over and over again. As long as I'm not doing any input, no events are occurring. There's probably some events in the background, but nothing that we should concern ourselves with. So what happens when I click, say, 1? Right? Oh, a 1 appeared here. I wonder how that happened. Well, there's the enter digit. What did it do? It took this data, treated it as a string, went and got the current input of this input box here. GTK, that's what I called it, input. I created a new string of length, the length of the current input plus the length of the key that was entered, which is going to be 1, plus 1, y plus 1. People keep forgetting that, even at this point. Why do I need plus 1 for a string? Null terminating character, exactly. Then create a new string to hold this new input. If it was 1, 2, 3 before, and then they clicked 4, now we're going to append 4 to the end. And we're going to create this new input here. We copy that over, we concatenate the new key, and then we reset the text of the input box to this new input, freeing up that temporary string, making sure that there are no memory leaks here. Imagine if we didn't do this one. Right? Then we would be leaking at least 2 or 3 bytes of data every single, probably more than that, on every single button click. Those would add up because this is going to be a long-running program here. Okay. Otherwise, again, if it's 2, 3, it just grabs this current input, appends whatever you type, whatever you've clicked to it, and then updates it up here, all in one shot. What happens when I hit the clear button? This clear input is called, and the only thing it does is it doesn't even care about what's already there. All it does is set the input text box to an empty string. Right? So clear, 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 clear. Even if it's already cleared, it just clears it again. So what happens when I go 1, 2, 3, 5, and then hit the enter key? That's where the enter password comes in. It goes and gets the current password and makes a check against this hard-coded password up here. Where is that stored? I think it's up here. What's my password? 1, 2, 3, 4. And if they're the same, it updates the label to this thing over here, which says access granted. If it does not match, it goes over here and says access denied. In either case, it will clear out the input by calling this other function over here. There was no button that initiated this action, so we pass in null and null. Don't worry about that. Right? So when I hit this, of course, it will say access denied. It's in red and it's bold. 1, 2, 3, 4. Enter. It's in green and it's bold. How did I get that? Does this look familiar to anybody? It's HTML, right? It's HTML and CSS. CSS is cascading style sheets. It's how you can get web pages to look well, here I've got the font color is going to be green and the font weight will be bold. Right? Here the font color is red and the font weight is bold. Right? Otherwise, normal, or I don't know what else is supported. Very bold? I don't know. Bold. Right, there we go. And this span tag right here, that's HTML saying anything between this tag right here and the closing tag right here, apply this, this style to it. So you can change the font. You can change it to a serif font, or you can change it to italics, or whatever else you want. GTK does support basic CSS like any web page would. So 200 lines of code just to get this very, very simple keypad demo here. Right? And that's I could have probably gotten it down a little bit more, but there's all the essential elements. Again, those essential elements are a way to create widgets, a way to create and specify a layout, and then finally a way to register events. If you didn't register any of the events, these buttons would be clicked, but they wouldn't be doing anything. Right? Just like if I click, I'm clicking right now, you can't see it because there's no event associated with it, but I'm clicking the label right now, right? And it doesn't do anything because I didn't register an event with it. I could have registered an event with this that upon clicking this label, delete the hard drive or something like that, right? So if you want to be malicious about something, then yeah, right, you can do that. So clear, enter, kill the entire thing. Any questions? Otherwise, again, if you want to, you can go ahead and try doing a lab 14. You will not be able to do it on the CS50 IDE, which is why we gave everybody credit and made tomorrow's lab a hack 14 workday. If you actually want to do the lab, you'd have to go in and to the lab, physically to the lab. You'd have to work on one of their computers, and you would have to go into the SUSE Linux partition in order to compile all this stuff. And even then, I think that it's kind of broken. I'd have to push a change to get it to work right now, because I had to push to do a change here to get it to compile before I came to class. Right? They're always breaking something every year on the CSE server. Any questions? Otherwise, every single widget or windowing system of all of them that I listed here are going to have the same three basic steps. GTK plus, right? You create widgets, you specify a layout, you specify callbacks. Even with something like Android Studio, where you've got a WYSIWYG here, you're still doing the basic, the same basic thing. It's just that Android Studio. It's just that you don't write code to do it. Instead, you drag and drop widgets in this IDE environment right here. But ultimately, you will have to do code over here to do callbacks, because you do need to write code. What happens when somebody taps that button, right? What happens when somebody makes the character in your game jump, right? And for games, that's a completely different thing. Those are completely different frameworks too. Right? This is basically like point and click kind of frameworks. All right. All right, when we come back on Thursday, we'll talk about databases. When we finish up with databases, we'll do as much, well, we could probably get it done next time so that we can use the entire dead week for review. We'll do as many exercises as we want.